Good morning, students. Can you hear me? Can you see the screen?
Morning, sir.
Learning.
Yes, sir.
All right, good. All right, so for today's class, so we have basically started our exam prep and revision. All right, we still have a few more things to do, but we are in exam preparation mode now. And today's class, I'm going to be working through the paper that I sent in the group yesterday. I think I'm going to do it over 2 days, today and tomorrow. So I'm going to do maybe half of the questions today, or a number of questions today, and then maybe some tomorrow. Also sent a paper one for you to do. So I also sent solutions and a video for those questions. So you are to redo any of the questions that you got wrong. It's very, very important. Every time you do a paper one, a multiple choice paper, we should use what we call a 100% system. Where any question you get wrong, you have to go and redo it. All right. And we are piggybacking on the fact that they repeat the multiple choice questions a lot. And even sometimes if they don't repeat it exactly, a lot of the times it's the same questions that they make adjustments to. And we need to fully understand those solutions. All right, not just what the answers. So we need to really know and understand how the questions are made so that when the minor changes are made, we are still able to do those questions. Multiple choice is very, very important. It values around 40% of your final mark. And so we cannot take it for granted. All right. Cannot take it for granted, and we um, cannot take a relaxed attitude towards it. All right. I'm a little bit under the weather, so I have a slight sniffle and a slight cough. So, I might have to relieve myself with a cough from time to time during the session. So excuse me if you hear me have to cough a bit. All right, but we still have to do this. Still have to roll. All right, so this is the paper that I sent to the group, to June 2023 paper. Also, I'm away, guys, and where I'm actually using internet in the facility that I'm on, and the traffic on this internet is very, very heavy. So might get a little bit of buffer every now and then, but let's do the best that I can with it. All right, so this is June 2023 paper. Usually I like to start doing these papers from the back, but I'm going to start at the front today because I realize that, not a lot of persons are on right now. All right, so I'm starting at the front in the hope that by the time we get to some of the latter questions, more persons will join. The session is also being recorded, so it will be available for those who are not able to attend now. I really wanted both groups to attend the session. In fact, all the online sessions now are to be attended by both groups, the Sunday group and the Monday group. Right. So all of that will be clarified as the days go by. But I don't like to see, I don't like to have a session and I see people missing, people absent, and that is the case now. But let's hope they go and watch the video afterwards. All right, let's get into it. The first question, I like to call it the calculator question. All right, this one, it says, find the exact value. And some questions and some papers will tell you to use a calculator to do it. All right, so we have to basically calculate that. Now, if you type this in on your calculator, exactly as it appears there, then calculator will give you the answer, and you're actually free to use a calculator. This is a calculator exam. Where is it? In the instructions, where is it? Trying to find where it says you can use a calculator. So it says, I'm not seeing, oh, right here, there it is. Electronic calculators are required. And you also require a geometry set for this exam. All right. So you are free to use your electronic calculator, non-programmable, and you can use the full capacity, full capabilities of a calculator. So you are free to use a calculator to work that out. But if you were to go step by step, what you must know is that you have to follow the proper order of operation, which you have to do this multiplication here first. All right. And get one expression for that, one fraction. And then you, that's a plus and a minus. You put it, then just work it from left to right. So after we get this value, which I can maybe do step by step this time, but I can put everything in the calculator. I'm going to do it both ways. I'm going to put everything in the calculator now and just write the answer, which is my preferred way, because I believe that if you're using a calculator, you should be free to use the full capabilities of the calculator. All right, so this is 2/3. And then I'm subtracting another fraction, 12 over 35. I'll multiply that with a fraction 7 over 9. All right, so if you look up here, say if you look up here, you will see where I typed out what is in that expression that was given. The calculator has given us an answer. You just have to make sure that you type the exact thing that is given in the calculator. And I always tell you that you must get one of those textbook display calculators, one where you can type your expression in exactly as it is presented. And so the answer on an exact number is this right here, or this one right here. All right, so I would maybe write this one and just put 37 over 30. But
Yes.
if you were to go step, mute a mic, please, mute a mic. If you were to go step by step and follow the proper order of operation, we'd have to work out this, as I said, first. And so it go 5 over 6 plus over 3 minus, and I want to work out what that is. Again, I'm going to use a calculator because I can use it. And it would be 12 over 35 times 7 over 9. See what fraction that is. That would be 4 over 50 right here. So I put 4 over 50 right here. And then because plus and minus, these really have the same, they are the same level in terms of the order of operation. And so if that is the case, you can just add these left to right. In other words, you could work these out first, see what you get, and then subtract that from the result. All right, but I'm going to also put everything in the calculator now, these three, and the answer is going to be the same. Let me just write on that. Let me just not waste time. 37 over 30. Final answer. All right, let's move on. And this one says we have to calculate, clearly you have to use a calculator for this one, and you have to give your answer for 3 decimal places. So you have to make sure your calculator is in degrees. You can see the DEG on the top of my calculator there. Some calculators will be a D or same DEG. Make sure your calculator is in degrees when you're doing these tricks questions. All right, we have questions with tricks. All right, so this is the square root. And then under square root, we're doing 1 minus. I'm putting it back as it is there. It is a cos 37. That's 37 degrees. We'll come from on the square root side. Put that and square it. And square that. And that is 0.6018. It's given plus or minus, but we're just going to give the positive. All right. When given a square root, you just take the positive. When given a square root expression, you take the positive. All right. All right. So that is to 3 decimal places. So it is 0.60181502 3 and so on. But they only want it correct to 3 decimal places. That's 1, 2, 3. 1, 2, 3. 3 places after the decimal point. Using this 8 to correct those 3 decimal digits, these 3 decimal values. So it turns this into a 2, or it turns this into 602. So 3 decimal places, this is 0.602. And that's his answer right there. Nice and easy. All right, what next? Here it says we have to write this in standard form. Standard form is where you have a number times 10 to some power. This number has to be in the form where you have one non-zero digit before the decimal point. Like for example, this has to be something like 9 point something. Right? You must have a non-zero digit. All right. So if I put this n, must be something looking like a number dot mean point. And you can put any number of decimal places here. This number has to be between 1 to 9. Must be between the numbers 1 to 9. One decimal point, one digit before the decimal point, one non-zero digit. So if I look at this number that they gave us, what it is that we need to get the decimal point right here after the 5. So we have to move it 1, 2, 3 places to the right. Now you'd move it 3 places to the right by multiplying this by 10 cubed. But to cancel out the multiplication of 10 cubed, we then have to multiply by 10 to the minus 3. That's a way to look at it. All right. Also remember that is a very small number. All right, because it's a very small number because of all these digits are the decimal point. And so you expect the power to be negative on the 10. All right, so you expect the power on the 10 to be negative because that's small number. Let me show you could make the adjustment. So it's 0.00527. And I'm saying, I'm using red and show the adjustment. I want the decimal point to go 1, 2, 3 units to the right. So to move the decimal point 3 units to the right, I'll multiply by 10 cubed. That will move the decimal point from it, but I have to now balance back out that multiplication by 10 cubed. And I so multiply by 10 to the minus 3. Then now, this inside the bracket here that I'm putting in the bracket will move the decimal point where I want it, and this will be a part of the result. All right, so that's a way to look at it, so a process. This will be 5.27 when the decimal point comes here. This move the decimal point for us, and I'm multiplying this back here times 10 to the minus 3. And this is the answer. Now there are some calculators, that can actually, if you put this in it, it will can tell it standard form, or they call it scientific notation. It will actually write this in scientific notation for you. There are some calculators that can do that for you, show you that this is the correct answer. All right, and then also if you're not sure, you could put this in the calculator and see if it gives you back this figure right here, which it would. All right, so if you want, you could just double check on the calculator if you're not sure. But with practice, we will be sure. All right, so that is the answer for that one. About the good so far? Are they okay so far?
Yes, sir.
Let's continue. So this is a consumer related question. All right, this one in particular looks like it's a payroll question, and you have to learn these things. All right, so it says Harish works at a call center for 35 hours each week. So this is his normal working time. Most times, the number of hours in a week is 40. But for some reason, this one is 35. That is a regular work time, 35 hours. He is paid a rate of $11.20. That's $11.20 for each hour. That's what it means, right? That's an hourly rate. It says calculate the amount of money Arash earns in 4 weeks. Remember, each week is $35, 35 hours. All right, so let's do it. Let's break it down. All right, so let's break it down. So when I say, okay, weekly, let me spend a little bit. So that's okay. Let's work out the weekly wage first. All right, so this weekly wage will be equal to 35 hours times this hourly rate. So it will be 35 times 11, 20. I use a calculator with that one quickly. 35 times 11, 2. That gives us $392. That is weekly. 392 weekly. Therefore, in 4 weeks, 4 weeks, right out of 4. As this month is 4 weeks. The wage simply gonna be 4 times this. 4 times 392. So when we just multiply this figure, we're going to calculate by 4. And that's going to be 1568. So this is his monthly wage for 4 weeks of work, and that's regular. All right, that answers that part. It says in a certain week, he works 8 hours overtime. All right, so overtime is the time that is worked more than the regular time. Remember, the regular time is 35, and now he's working 8 hours more than 35 in that particular week. It says overtime hours are paid at 1.5 times the usual rate. Sometimes they don't bother to say 1.5 the usual rate. They just say it's paid at a rate of 1.5 or 1.5. What that means is that we multiply this regular rate of $11.20 by 1.5. That is the hourly rate for overtime. All right, and we can just do a quick calculation here. Let's say OT meaning overtime. So overtime rate becomes 1.5. We can put 1.5, same as 1.5 times. I'm going to have space and put it here. Put it here. Let's work out overtime rate times the 1120 and show that calculation, show that figure. That's more than likely we're gonna need it. All right, so let's work that out here. Let's see what the overtime rate is for overtime. So that is 1.5, 1.5 times the regular rate, 1120. That's 1680. The 0.8, remember, is money, so you can't put 16.8. It's money we're talking about. So it's 16.80 because it's money. I can put 0 there. All right, so that is it's overtime rate. So for the 8 hours, he's working 8 hours times this. 8 hours of overtime time. Let's see what I want. It says find this total amount of money earned. So they don't only want the overtime, they want the regular for the week plus the overtime. That's what the total is. They don't only want the overtime. For that week, they want the total wage. Total wage is going to be the regular wage plus the overtime wage. Shift this over a bit. I just put it some notations for you to see. Because they want the total. They don't only want the overtime, guys. Just to pay attention. Don't go calculate just overtime alone. Read it carefully. So remember, we had worked out, fortunately, we had worked out the weekly wage here. So we have it. So that's a weekly wage, a regular weekly wage for 1 week, just 1 week for that week. So that is the 392 plus the overtime now is going to be 8 times this overtime rate. We can just put one calculation for that. 8 times the overtime rate of 16.8. Then if you put everything in the calculator here, we're gonna get the answer. So we're gonna go 392 plus 8 hours at 16.80. And so you would earn for that week 520, 526.40. 526.4. You remember you have to put a 0 on the end of this, because money is always expressed to two decimal places. So don't go putting 0.4. All right, it's talking about money. All right, that's the end of the first question, guys. Anybody good? But okay with that?
Yes, sir.
All right, hope we all got the full 9 marks for this question. All right. Okay, let's go. This second question now. Firstly, part A, they want us to simplify this. It's a multiplication of fractions. Whether it's numerical or algebraic, you basically, you cancel down values that has common factors. So here, look at this. The 4 and the 16 have a common factor of 4. So we can divide 4 out of each of those. Let me use the ready to cross. So 4 into this is 1 time, 4 into this is 4 times. Then now, if you look at the number 5 and the 15, there's a common multiple, or a common factor, I should say, of 5. So those can be divided by 5. So I divide this 5 by 5, I get 1. Divide this 15 by 5, I get 3. And then this x can cancel out this x. So there's a different color to cancel it out. So this x divides out with that x. So the values that we have left multiplying are this 1 times 3 and this 1 times 4. So the 1 times 3 is 3 and the 1 times 4 is 4. And that's the answer in lowest form. When this is simplified, guys, that carried out the lowest form, you can just cancel out a part of it. This cannot be cancelled or simplified any further. And so that is the answer right there. All right, next question. This is now a simple linear inequality to solve. Remember, solving this is the same step, same process, same procedure really as solving an equation. But this was an equal sign. 12 minus 4m equals 5 minus 8m. Same steps to solve this, same steps to solve that. The only difference, guys, is that with this one, the inequality, if there comes a point in the process where we have to multiply or divide with a negative number, we have to remember to reverse the inequality sign. All right? So solving this though is a matter of grouping the unknown. Solve means find the unknown. The unknown is m, right? So, excuse me. You're going to group the m values on this side, or you're going to group them on this side to make m the subject. All right, I'm going to do 2 ways. I'm going to do one where I group them on this side, and I'm also going to do grouping them on that side, just to show it different. And I also want to ensure that we get a chance to practice dividing or multiplying with a negative number. All right, so let me do it 2 ways. All right, so doing it the first way here, I'm going to try to group the m on the left side. All right, so let's go. So same as you would solve this in a guide, to transpose it. All right, so I don't want this 12. I want to take the 12 on this side, so I'm going to be left only with the negative 4m. I'm not going to move that negative 4m, so I'm going to leave that negative 4m on the left side. And then now this 8m, I want it over on the right side. So I'm going to bring it over to the right side and change it to a positive. So I'm going to get a positive 8m. Let me shift this a little bit. I'm going to get a positive 8m. The sign stays less than because I did not multiply or divide. So this sign stays less than, so less than or equal to. So this 5 is there on the right side. And as I said, this 12 comes over on the right side and becomes a negative 12. Same as subtracting 12 from both sides. All right. And then this now, this becomes 4m. 8m minus 4m is 4m. The sign stays less than. And then this becomes negative 7. 5 minus 12 is negative 7. Then to make m the subject, now like we're dividing both sides by 4. But the shortcut is to say we take this 4 and divide it on this side. And so we end up getting m less than or equal to -7/4. Right? Doing it another way, let me use a different color. And do it another way. So we can say, or we could put the m on the right side. So I'm going to leave this 12 over here this time. And this 5 will come over on the left side, over -5, or we say we subtract 5 from both sides. The sign stays less than because I'm not multiplying or dividing with a negative number. Then on this side, I have my -8m, but then this -4m comes on the right side and become a +4m. So I will get a +4m. And then this -8m is already on the right side. So that stays there. Then what would happen is that this now becomes 7 less than or equal to, now this is 4m minus 8m. That's a negative 4m. Then now we need to divide both sides by a -4. We have to divide this side by -4, divide this side by -4 in order to move this -4. But then now, because we're dividing with a negative number, we'll have to reverse the inequality sign. All right, so let me write that part out in red. I'm going to divide by -4. And I have to remember to reverse that less than or equal to sign because I'm dividing with a negative number. Here, when I divide with a +4, when I divide with a +4 this time over here, I kept the inequality sign the same because that is a positive number I'm dividing by. In this example, doing it this way, I'm dividing with that -4 now, and so the sign has to be reversed. So reverse that less than sign. You have to remember this, guys. And so this expression, I divide this by the -4, like I would get 7 over -4. This sign is reversed to greater than or equal to, and this side becomes m because I divided with that -4. Now this is saying that this expression is greater than the m, which can be read the other way from right to left, which is to say the m is less than or equal to that expression. So we just turn it around, we'll get m less than or equal to, and this 7 over -4 is the same as -7/4. And so we're getting the same result, All right, everybody good with that?
Yes, sir.
They're not gonna do it both ways, guys. You're gonna do it one way, all right? One of the 2 ways. All right, you're not gonna do it both ways. I just did it both ways. Just to emphasize the difference when you divide between a negative number versus a positive number. All right. Don't need the calculator on. This. All right, so this question says, this question gives us this compound shape. And it says like made from 2 rectangles. So the length in the diagram, which are written in terms of x, are in centimeters. So all these dimensions are centimeters, all right? And then we have a couple missing dimensions. This one is missing, and this one is missing. So you have to deduce those, all right? So I guess that's a part of the question. Most answer for that. There you go. It says find an expression in terms of x for PQ, which is this side. All right, so okay, we get that out now. This is a square diagram, right? So this length is 3x. And so all of this would also be 3x. But then this length right here is the same as this length right here. All right, so everything is 3x now. This length is part of it is x plus 3. So it means that this piece down here has to be 3x minus x plus 3. That's what this part is right here. This part, the PQ becomes 3x minus the x plus 3. Note that I put x plus 3 in a bracket because I'm subtracting the entire x plus 3. All right, so I'm just going to write it here now. And tell me if you understand. So it becomes 3x minus in bracket that whole length of x plus 3. Then let the negative do what does it do its thing. So it becomes 3x minus this x is 2x. And then nothing minus a negative 3 becomes minus 3. But understand that? Are you okay with that?
Yes, sir.
Remember, I know it's people who don't understand, you need to speak up, and if they don't understand, talk. So this side we know is 2x minus 3. So let's put on the diagram. All right. So this side is 2x minus 3. The next part is asking us for the other unknown side, which is r cubed, which is right here. So again, let's go for the red right here for what? Now we know that the total length across here is this 4x minus 5. And then this little piece right here is the same as this x plus 1. And so this length that we're trying to find has to be 4x minus 5 minus x plus 1. 4x minus 5 minus the x plus 1. Be careful and bracket up those compound expressions. All right, and that's going to give us that length of r cubed, 4x minus 5 minus x plus 1. Let's put it down here. So this length down here is equal to 4x minus 5, and then we're subtracting x plus 1. Yeah, we're careful with that negative. So the final answer becomes 4x minus x. That's 3x. And careful now. Negative 5 minus 1. That's a negative 6. Negative 5 and negative 1 is negative 6. And that is the length of that cell. Let me put it on the diagram here. This length right here, we say is, what is it? 3x minus 6. This is 3x minus 6. But okay with that?
Yes, sir.
Yes, sir.
It's part one, just to, given that the total area is this, we have to show that expression. And to show an expression is basically almost like you're trying to work out the information that they tell you. They tell you that the area is 414. To show this expression, you go about getting an expression for the total area, put it equal to the 414, and this will just basically work out itself. That's how you do it, right? The information that they tell you, just put it in a mathematical expression based on what they tell you, and it will result in this. The total area is 414. So we need to find the two sides, the two shapes that we're going to add. So break it, the compound shape, break it down into parts. So either you break it this way, and use this triangle, this rectangle, and that rectangle, or you can break it this way, and use this rectangle and this rectangle. It doesn't matter how you choose to do it. All right, the result is going to work out the same. All right, let's say I'm going to leave it like that as I have it now. I'm going to break it down like that. And this area is going to be these two dimensions. And this area is going to be these two dimensions. All right, so we're going to say, let's go. That total area becomes 414. So let me call it area 1 up here, rectangle 1 and rectangle 2. All right, and total area is 414. Let's go. All right, so total area is 414. That's what we're going to, this equals that. So we can say, therefore, area 1 plus area 2 equals 414. And I'm leaving the 1 and 2 that I've marked on the diagram. Now, area 1 is 4x minus 5 times x plus 3. That's 4x minus 5 times x plus 3. That's area 1. Plus this now area 2. Area 2 is broken up these two dimensions. This was 2x minus 3. 2x minus 3 and x plus 1. X minus 3 and x plus 1 dimensions of area 2. X minus 3, x plus 1. That's 2x minus 3 x plus 1, that is 4, 1, 4. What happened now? We'll simplify this expression. It is supposed to come out to be this. So that's what it is all about. But first, you have to do multiply these two bracketed terms. All right. So it's this value times each of these plus this value times each of these. All right. So let's do this value first. So it's going to be this value times each of these. That will be 4x squared. I'm going to multiply this times this. And I multiply it with the 3 becomes 12x. I'll put up plus 12x. Then we're going to negative 5 times x now, negative 5x. And then negative 5 times positive 3, negative 15. All right, and then we're adding this expansion now. So I don't have the brackets, right? I can just add and just put what to get because I'm adding the expansion. So it's 2x times this x versus 2x squared. And 2x times this 1 is 2x. Then minus 3 times this x is minus 3x. And then minus 3 times this 1 is minus 3. And that is all equal to 4, 1, 4. Based on the fact that they have 0 here on that side, this 4 and 4 is going to have to come on this side. But let's simplify it a little bit first. So we're going to group all the like terms, all right? So this is 4x squared and 2x squared, that is 6x squared. And the terms in x, now these two is giving me 7x, let me write them on top here in red. These two giving me 7x, put it on top here. And these two giving me negative x, put it on top here. So the like terms are 7x minus x. All right. If you wanted, you could have worked all of these together. The result will be the same. But I'm just saying that these two is 7x and these two is minus x. 7x minus x is 6x. That is 6x. So that's plus 6x. Now we're working the constants now. So this is negative 15 and negative 3, that's negative 18. And that's equal to 4, 1, 4. I'm going to take this 4 and 4 and bring it away and I think I can divide through by 6 now. And it looks like I can divide through by 6. This divided by 6 is not this. I divide through by 6 right now and simplify it. And that's what that is. I don't know what I'm doing by calculator. Let's do it over here. It's 4 divided by 6. That's 69. So this is 69 divided by 6. What is right? Right by 6. It's not the only way to do it, right, guys? You can just simplify it. So divide 2 by 6. This becomes x squared. This becomes x. This becomes negative 3. And this becomes 69. Then this 69, when it comes over here, now becomes a negative 69. The negative 69 and the negative 3 give me negative 72. So I'm going to get the x squared plus x minus 72 equals 0. And that has been shown. It's the same expression that it told us to show up here. Here it is. And then it asks us to solve it, just show it. All right, so the question is done. That's it. Better go to that.
Yes, sir.
With this one. All right, let's look at this one. Number 3. So number 3 says the diagram below shows a semicircle with a diameter AC. It says B is a point on the circumference and AB equals BC is 8.2. So this side and this side is the same 8.2. Look at 8.2 on the diagram here. This is also 8.2 centimeters. So therefore, that's an isosceles triangle. Now remember that a diameter subtends an angle of 90 degrees at the circumference. Angle subtended by a diameter is 90 degrees. So this angle here is 90 degrees. All right. So, we're putting in that on the exam paper. we're saying to the exam that that angle is 90 degrees. It says state the geometric name for the line AB. So this line AB, it connects 2 points on the circumference, and so it's a chord. That's it, a chord. And it says find the value of the radius of the circle. All right, so looking at this diagram, I'm seeing multiple ways to do it. Now, one way to do it quick and fast is to find the length of the diameter and then half it, half the diameter. And this is a right angle triangle we have here now. And so we can use Pythagoras' theorem in it. Simple as that. And this will be the hypotenuse in that right angle triangle. All right, another way to do it is to maybe divide this here. And this will be a radius. And this will be a radius as well. And we could work in this right angle triangle again, and then this will be the hypotenuse. But I think the first way I'm looking at is the easier way. Let us not complicate it. I'm going to find the length of the diameter and divide it in two. All right, so we can say it like this. We can say the radius. All right, so find the radius. I'm going to call it R. I'm going to say the R is equal to half AC. And then what is AC? AC using Pythagoras' theorem becomes the square root of this side squared plus that side squared. And these are the two sides in the right angle triangle and not the hypotenuse. And so it is 8.2 squared plus 8.2 squared. Whatever the character given for that is your answer. Let's look at it. And get the calculator and do it here. But that's another calculation there. Are you okay with that?
Yes.
Good. So recognizing that this angle is a 90-degree angle was very good in this question. All right, very good for the solution of this question. All right, so we're gonna do a half. I'm gonna multiply that with the square root of 8.2 squared plus 8.2 squared again within 5.798. If we got three significant figures, that's going to be 5.80. So 5.80 centimeters approximately. Gives you three significant figures. All right, because look at it this way. If you have 5.798, all right, and I decide that I want to correct it to three significant figures. These are the first three significant figures. So this 8 must correct this 79 that I have here. I'm writing properly. Write it properly. 5.798. All right, so I'm saying this 8 will have to correct this 79 and turn it into 80. Okay, so that's what becomes 5.80, and I'll leave a 0 there to show that I'm expressing to three significant figures, which is a standard to which you give your answer when you're told what level of accuracy answer is supposed to be. That is not exact. All right, but that is it. Are you okay with that? Are you good?
Yes, sir.
Wait, sir.
Yes.
Can you repeat why you'd have to square root it again, please?
By square root, because remember I'm using Pythagoras' theorem in the triangle. I'm using Pythagoras' theorem. Remember, Pythagoras' theorem says that if I'm treating this as a right angle triangle, this is the hypotenuse, then the AC squared, the hypotenuse squared, would be equal to this side squared plus this side squared. It would be 8.2 squared plus another 8.2 squared. Because AC I want. So to get rid of the square, I have to square root both sides, square root, square root. So the AC is the square root of 8.2 squared plus 8.2 squared. That answers it.
Yes, sir. Thank you.
Let's continue. This one says each interior angle of a regular polygon. Remember the word regular, a polygon means all sides are equal, all angles are equal. That's why it says each of the angles is 160. And what this question wants us to do is tell it the number of sides. Remember, number of sides and number of angles is the same. But this can be done in multiple ways. I think I'm going to do it the easier way first. Because if an interior angle is 160, then the exterior angle is 20. Because the total, the sum of the interior and exterior angle must be 180. Remember that for any polygon, total exterior angle is always 360. And we can use that approach. So let's look at it this way. Let me do it an easy way first. Using the exterior angle, total exterior angle is 360 method. So since the interior angle is 160, we can say each exterior angle is 180 minus 160, which is 20. All right, and the total exterior angle is 360, and each of them is the same. So if this polygon has n sides, let's say it has n sides, that's a good way to always to call the number of sides n. N sides, n angles. We want to say the total exterior angle is 360. So total exterior angle is 360. This is a knowledge that you must have. And the total exterior angle is going to be the number of sides, number of angles times 20. So then it would mean that n number of sides times each one is 20 degrees is 360. And therefore we divide by the 20, we get the number of sides. So the number of sides would be 360 divided by 20. We can chop off the degree, don't need the degree anymore. That works out to what? 18. So n equals 18. That's one way to do it. Let's look at another way. Let's shrink this a little bit and do it another way. Make this a little bit smaller. Do it another way. We want to focus now on the interior angle approach. So the exterior angle approach is a nice way to do this question because the total is 360. Any polygon, it doesn't matter. Any polygon, the total exterior angle is 360. All right, so I'm going to use the R method now. We are focusing on the interior angle. So each interior angle is 160, and there are n of them. All right. So when I look at this method now, I want to say the total interior angle is n minus 2 triangles. Remember, total interior angles is n minus 2 triangles. I remember I gave you that in class. Total interior angle. A polygon can be broken down into n minus 2 triangles, where n is the number of sides, number of angles. So I'm going to write n triangles. Each triangle is 180 degrees. Sorry, not n minus 2. That is smaller. Each is n minus 2 triangles. No, the total is n minus 2 triangles. So the total is n minus 2 triangles, n minus 2 triangles. But each triangle is 180 degrees. Instead of putting triangles there, I'm going to put 180 degrees. So the total interior angle is equal to this formula. And that's a good formula for now. A way to remember it is to remember that a polygon can be broken down into n minus 2 triangles, where each triangle is 180 degrees. But since there are n angles in there and each of them is 160, then this total angle is also equal to 160 times n. So I can say then that 160 times n, and 160 degrees times n is equal to this thing. And I can expand this now. So it will be 180 times n And then the 2 times 180 is 360. I'm subtracting that. Then now if we just simplify this, take this 360, bring it on this side, make it positive, and take this 160 and bring it on this side and make it negative. Then I will get 360 degrees equals 180 degrees n minus this 160 degrees n. And then 180 minus 60, 180 minus 160 n becomes 20 n. And this remains 360. And so we'll come back to the same place right here. I should say right here. Because I need to divide this 20 degrees. So I get 360 degrees divided by 20 degrees. That's what is the n. So you get the same thing as we have here. That's 18. So n equals 18. 18 sides. Everybody good with that?
Yes, sir.
Yes, sir.
Did somebody said no? Everybody said no? Everybody okay? Everybody all right? All right, I guess everybody's okay. All right, so get familiar with this method over here. Here, guys, total X is 360 is very powerful way to do some of these questions. Quick and fast. All right, let's continue. All right, here is a transformation now. This one says the diagram below shows a trapezium A. It says drawn, it is drawn on a square grid, on a square grid. What are we to do with it? It says on the diagram above, draw the image of E after it undergoes a reflection in the line x equals -1 and leave it A prime. So to reflect in the line x equals -1, we have to show the line on the diagram. Just to be seen. I know that when you do a reflection, image distance must equal object distance from the mirror line. Mirror line is x equals -1. Now, x equals -1 is a vertical line passing through -1. We have to get that right. X equals a number line is parallel to the y-axis because the y-axis, remember, is x equals 0. So x equals -1 is going to be parallel to the y-axis just as it passes through -1. All right, so a vertical line passing through this value. So this will be a mirror line. That is x equals -1. I'm reflecting this trapezium with 1 point at a time, guys. Image distance equals object distance, right? So this point, get this off. Right now. Battling a cold, guys. Battling a cold. All right. So this is 2 points to the mirror line. This point here is going to go 2 points to the other side over here. We'll draw it again. 2 points to the mirror line, 2 points on the other side. It's coming to here. That point with 1 point at a time. At this point now, it is 4 units to the mirror line. It's going to go 4 units on the other side over here. That's this back point. And then this point, back again, it's coming all the way 4 units again. 1, 2, 3, 4. It's going to go 4 units on the other side. It's going to go directly above where this point is. It's going to above this one, right? So it's coming all the way to above here. Here. All right. And then you look at it and say this point is 3 units. 1, 2, 3. It's going to go same 3 units. 1, 2, 3 to here. Then you have to points and place, you draw the shape. And remember, orientation must be reversed. When you reflect in a line, orientation is reversed. And it's must label this one. A prime. All right, that's first one. Next one is for us to do a translation for -7. No, the translation is a movement, right? So it's going to move 4 units to the right, 4 units to the right. Each point is going to move 4 units to the right, And this negative 7 means you're going to now move afterwards 7 units downward. That's a negative 7. That's what negative 7 means. So each point is going to do this movement. 4 units to the right, 7 units downwards. Now, for a translation, what you can do for a translation is move 1 point and then draw about the same shape around that 1 point. All right, so we can do it that way. Almost for translation, nothing changes but position, right? Everything stays the same. So for focus and say we're going to use this point as our base starting point. We got point 4 paces to the right and 7 units down. 4 units to the right, 7 units down. So it's 1, 2, 3, 4, and 7 units down. 1, 2, 3, 4, 5, 6, 7. The expect was here. That's where this point ends. All right, and then what I can do is draw about the same shape. Majority of the blue. Draw about the same shape of this around it. So this base side is 2 units. I'm going to put it back here, 2 units. This side is 2 units up, the back 2 units like that. This top piece is 1 unit, put it back 1 unit. And then close it with this diagonal piece. Or that slant piece, not diagonal, slant piece like that. And this must leave it A double prime, A double prime, A double prime. If you want, you can check our point. For example, check this point. 4 units to the right, 7 units down. See if it's correct. 1, 2, 3, 4, 7 down. 1, 2, 3, 4, 5, 6, 7. That's it, it's correct. All right, so that is it. So this is it, guys. So I'm leaving this on the diagram to show the 4 and 7. So this is a 4, and this is a 7 down here. And negative 7, I should say 7 down, negative 7. Gotta go to that.
Yes, sir.
All right, so that finishes that one. Then we'll come to number 4. Number 4 is a functions question. That's a rational function. You have this on the denominator. And you have 2, it's a linear function. That's a 4, it's a quadratic function. All right. It says for what value of x is f of x undefined? This one. Remember, function becomes undefined. The denominator is equal to 0. The fraction cannot take 0 on the denominator. It becomes undefined when, let me put it here, it becomes undefined when the denominator x plus 2 is equal to 0. That is when x equal negative 2. Another way to could have expressed this question is to say, state what value of x cannot be in the domain of f of x. What value of x this function cannot take. It cannot take a value of negative 2. Because if you put negative 2 in there, it's going to cause the denominator to be 0. All right, so you cannot take a value of negative 2 in the domain and that function. All right, so that is that. But I'll go to that one.
Yes, sir.
Yes, sir.
And the g of a quarter now, g of a quarter here means that we're going to substitute a quarter in the g function there where it exists. Simple as that. So this becomes 4 times a quarter minus 5. Now 4 times a quarter is 1. It's 1 minus 5. Then 1 minus 5 is negative 4. So that's negative 4. Negative 4. All right, better go to that.
Yes, sir. Yes, sir.
All right, then h of negative 3 now means that we're going to take negative 3 and put it in the h function where it exists. All right, now we're going to square that negative 3. So this one is going to become negative 3 all squared. And then we're adding 1. Remember, when we square a negative number becomes positive. And so this becomes 9 plus 1. Final answer is 10. Final answer is 10. One second, one second. All right. Everybody good so far? Everybody okay?
Yes, sir.
All right. Then we need f of 0. Remember, this f of 0, they could have instead, they could have written also f squared of 0. Means the same thing. All right. So instead of saying f of f, remember, they could have said f squared. So if they give a f squared, they must know that it means f of f. And all this means is that I want to put 0 in the f function first, see what it is, and then put that result back into the same f. Let's see what f is again. F is 3 over x plus 2, and write it here. f of x is 3 over x plus 2. All right, so this now means that's firstly on what called f of 0. f of 0, we're doing this f of 0 first. So the f of 0 is coming here, which means we're going to put 0 in the f function first. So it's going to become 3 over 0 plus 2. All right. Which becomes f of 3 over 2. Understand that so far? So inside there
Yes.
is f. Good. And then now we need to do f of 3 over 2 now. So it means that we have to put now the 3 over 2 back here again. So this part becomes 3 over where this x is. I'm putting 3 over 2 and then adding back this 2. Now, if you want to put use a calculator, work this out, but this is easy to simplify because get rid of this fraction on here. What I could do is multiply the denominator, this whole denominator by a 2, and then also multiply the numerator by the same 2. So that I can multiply by a 1. Then if you simplify that now, just express a little simpler. 3 times 2 up here is 6 over this 2 times 3 over 2 becomes a 3. The 2's cancel. And then this 2 times this 2 is a 4. So it's a plus 4. Then this 3 plus 4 is 7. So the final answer is 6 over 7. That is it. Very good with that. Any questions?
No questions, sir.
Beautiful. Let's continue. Then this one says write an expression in the simplest form for g of h. Remember, g of h, when you're putting h into the g function. All right, let's write all the two of them. All right, so the g of x, what again? I think it was x squared. Something. X squared plus 1. And the h, no, the h is x squared plus 1, and the g is for x minus writing, and I'm popping it up. So the g of x is 4x minus 5, and the h of x is x squared plus 1. Just copy them down, so I don't forget. Yeah. And then show on all the substitution. Right. So the g of h of x, as I said, it means the h function into the g function. And how we do that is I would take the entire h function and substitute it into the g function wherever we have an x. So all you have to do, quick and fast. Keep it simple. So you're basically constructing that substitution. So the 4 goes back. Where the x is, I'm putting back all of the h, which is x squared plus 1. You bracket it up. So that replaces the x that was here. And then you know subtracting this 5. And it says simplest. So we need to simplify the expression. So If 4 times the x squared is 4x squared. Then you have 4 times 1 is 4. Minus back this 5. And it is 4x squared. And 4 minus 5 is negative 1. That is it in simplest form. But go to that.
Yes, sir.
Yes, sir.
Excuse the coughing, guys. Please excuse the coughing. Then this one wants g to the minus 1 of 2. All right, let's do this a neat little way. All right, let's do this a neat little way without finding the g to the minus 1 first. So they want us to find g to the minus 1 of negative 2. We're going to put that equal some value n. We don't know. Let's just call it n. Now, if that is the case, it means that negative 2 is equal to g of n. I'd like to take the inverse and then put the inverse of the inverse on that side of that value. So that is g of n. So it means that g of n is equal to the negative 2. If you put g of n equal negative 2 and calculate the n, then you'd have basically answered this question. Now, what is the g? Remember, the g is this 4x minus 5. So this g of n is 4n minus 5, and that is equal to negative 2. So now we're just solving for the n. You still have to do some form of transposition in the process. The same transposition you have to do to find the g dimension of x first if you're using that method. We still have to do the transposition here. So I want to make n the subject now again. I'm going to add this 5 over here and then take this 4 and divide it under. All right, so take this 5, bring it over here, and it becomes a positive 5 minus this 2. And I will take this 4 and divide it under. So divide that under there, that gives us this n. All right, and then that works out to be 3 over, not 4, not 4 here, not 2. Divide this 4 and here. 4. Then the 5 minus 2 is 3. So 3 over 4 is equal to the n. So that means that this is equal to this 3 over 4. So we can say therefore the g to minus 1 of negative 2 is in fact 3 over 4. That is it. That's a nice way to do it. All right. The other way to do it is to find the inverse first. All right. We'll do that too as well. More maths equals better maths. We'll do it right here. Let's do the OR method here. So the method we're going to do it is to find the g to the minus 1 of x first. So right, g to the minus 1 of x first. Then we substitute the negative 2 in it. G to the minus 1 of negative 2. That's the second method, or the method that most persons would use. All right, so to find g to the minus 1, remember what is the g again? G is 4x. 4x. Pass it. I passed it. The g is 4x minus 5. So I'm finding the inverse of that first. So I'm going to say, okay, the g is 4x minus 5. I'm just leaving out the x. And so inverse on these expressions, this g becomes x equals 4 times this x is g to the minus 1 minus this 5. And I'm trying to make this a subject again. So we take this 5, bring it over here, make it positive, and then divide on the 4. So you do the same thing. It becomes 5 plus x over 4. And that is your g to the minus 1. Oh, that's a g to the minus 1 of x. G of x right here. And so if you want g to the minus 1 of negative 2, you're going to plug in the negative 2 here and there. You can say therefore, g to the minus 1 of negative 2 is that negative 2 is coming here. So then it will become 5 plus a negative 2 with x is over 4. Now this up here same as 5 minus 2, which then becomes 3 over 4. Just the same as that. All right, and that is it. But okay?
Yes, sir.
Good. That's so long ago. But I want to divide this class and do the second part of it. Second part of it. All right, let's continue. Then we come to this question that we did the other day. No problem. More maths equal better maths every time. We did this question the other day. All right, so let's do it again. It says, each of 75 girls recorded the name of her favorite sport. So the number of girls who chose track and cricket as shown in the bar chart. So this is a track and this is a cricket. All right, and we have a scale up here, and we can basically start to identify those numbers. Let's put them on in the red. So this one is 12 on top of that. So it's 12 girls like track, and on top of this one, but really scale carefully now. So this is 0 and this is 4. So here has to be 2. This is 4 and this is 8. So here has to be 6. So 8 and 12. So here has to be 10. Then here has to be 14 and 10 continues, and here has to be 18. So this is right between the 16 and the 18 right here. So that is 17 up here. All right, 17. So it says, how many more girls chose cricket than track? So the difference between these two numbers. All right, so it's 17 minus 12. 17 minus 12 is how many more, and that is 5 girls. What go to that?
Yes.
All right. It says 11 girls recorded tennis as their favorite sport. It says for the remaining girls, the number who chose swimming compared to the number who chose football is in the ratio 2 to 3. And that's the ratio. This ratio 2 to 3 is of the remaining girls comparing swimming and football. All right. So 11 girls like tennis. Let's put on the tennis on this thing. This is the tennis and 11. So 11 will be right between the 10 and the 12 on the tennis column. So the tennis column will go to here, or the tennis bar, I should say. Go to here, to 11. Let's just put it in, right? I mean, you know this question, but I'm going to answer the short. So that's right. Right, and shade it. So this is 11 here. And the total number of girls, remember, was 75, right? And these two other activities are in the ratio 2 to 3. So this is 2 parts, 3 parts of the remainder. All right, 2 parts of 3 parts. So the question is 2 to 3 is in the ratio. So the question is, what is the remaining? How many remain? So it's 75 minus these that we have so far. We'll put it down here. So the remaining girls is 75 minus those 3 numbers that we have. Let's work it out here. 75 minus the sum of those that we have. So 11, 12, 17. 11, 12, 17. And I'll work that out. So 75 minus those. Split here. So 75 minus 11 minus 12 and minus 7. 35 girls left. And those 35 are now in the ratio. And is the ratio 2 to 3. It's 35. All right, so let's just set up like a ratio thing quick. So it is swimming the football. Let's put S to W. No, S to F. It's 2 to 3. I know the total is 35, so we can extend the ratio from total. I like to do that. Total remaining, and that's REM for remaining. So we're going to extend that to 5. But the actual number remaining is 35. So we need this actual remaining to be 35. So we're going to multiply it up to 35 with a 7, multiply by 7. We carry it up to 35. As I multiply each of these parts in the ratio by the same 7. So this is going to become 3 7s 21, 2 7s 14. So these become the actual numbers. The actual number for swimming is 14. The actual number for football is 21. The 14 and the 21 is 35. So we have that now. So the question says, use information to complete the bar chart. So to complete the bar chart, we need to put in 14 for swimming, 21 for football. All right, 21. And write it here. So swimming is 14. Football is 21. So swimming going up to 14 right here. It's 14. 14 is up here. All right, that's a swimming 14. And then the football over here is 21. And then football bar up to 21. It's 21. This is 20. This will be 22. The 21 is right on in between here. And the football bar going up to there. So basically this is it. You have to do these things with a ruler, guys, and be neatly, right? Don't draw it 300 line. 21. Then I'm going to put the 21 on top there. If you add up these values, you must get back your 75. Put a number of curves. All right. So far, so good with that, guys. Far, so good.
Sir.
All right. And it says determine the mode of sport. The mode of sport is the one with the highest bar. Football. Football. That is football. You have to put this one. Maybe a different color. Sorry about that, guys. Sorry. I'm struggling here. Struggling. All right. Okay. Motor sport is football. Okay, more question. It says one of the girls selected at random. What probability that she chose neither track nor cricket? So if you chose neither track nor cricket, means that you chose one of the others, right? One of the others. So you know how many persons go through the others. And it will be 75 minus the number for track and cricket. The number for track and cricket, remember they were 12 and 17. 12 and 17. That's how many people do the other sport. That's what you want them. That's what you want them to do. You want them to do neither track nor cricket. So you want one of the others. So that is 75 minus 12 minus 1 minus 17. It's 46. And that's what you want. Probability of one of the others. So the probability of one of the others. I'm calling it others. Neither track nor cricket. This means either one or the other, right? It's 46 over 75. And that is it. 46 over 75. But this one I'm simplified. I'm going to simplify it. I think we are quick, but I'm just leaving it like that for now. But okay with that? Very good. Oh, still one other question. It says information on the favorite sport for the 75 girls shown on a pie chart. Yes. Calculate the sector angle for football. You know, football was 21, right? Football was 21. Yes. Out of the 25, out of the 75. So football, remember, is 21. And the total is 75. So you want to express 25 out of 75 and a fraction of 360 degrees. For the total in the pie chart is 360 degrees. So the angle for football would be 21. That's the number for football. Over the total number is 75. As a fraction that football is a total. And the total angle is 360 degrees. So this is a fraction of 360 degrees that will occupy the football sector. This is calculated. Get a calculation and get that angle. Let's see what it is. It is 21 over 75 as a fraction of 360. That's 100.8 degrees. 100.8 degrees. That's the answer. But go to that. Right, okay.
Yes, sir.
All right, I'm gonna do this question and then I'll just break today and then we'll do the rest of the paper tomorrow. All right, so those of you who did not do the questions, you're going to do them. And those of you who did the questions and you got anything wrong, you go and redo the question. That's how you learn from your mistakes. And that's how you eliminate mistakes by redoing anything that you got wrong. Even if you know you understand it, you put pen to paper. Don't just say, yeah, man, I understand it now. You have to work the questions. All right. So I want everybody to go and work these questions. If you didn't do them before, you go and do them now. And if you did it and you got anything wrong, any question you got wrong, you just redo the work question. I'm going to post a video in the group as well. All right. So let's just finish off with this question today. And then we'll do the rest of them tomorrow evening. It's going to be recorded. So those of you who cannot attend live, it's going to be recorded. So I'm going to do it in the time for class. So I remember I'm away. That's it in the group that I'm away. So we're going to have it class online until I come back. All right. So let's do this question. This question says, and this question take part in, once you see this, you know that you have some circle I'm just doing, right? Once you see that, that relates to circles. And it says the volume of a cone of radius R, that's radius of the base, and height H is given as this. I told in the class that when they give you these pyramid shaped objects, right? Pyramid and cones, they're going to give you the formula to work it, right? Especially if it's not on the formula. So this is a formula for the volume of a cone, 1/3 pi r squared H. All right, it says now the diagram below shows a sector OMRN of a circle, center O. The radius is 12 centimeters and the sector angle there is 168 degrees. So everything that I've said here so far, you can see them on the diagram. So this is 12, this is also 12. That's a radius. All right. It says which forms, it says form that using a thin sheet of metal. All right. So this is a thin sheet of metal. So it's in that shape. It says calculate the perimeter of the sector above made from the thin sheet. So we need this arc length and this radius and this radius. Perimeter the distance around it. All right, the question is now, what is this arc length? The arc, remember, is a fraction of the circumference. You can actually just put calculation right here. Sorry. Let's do it. So the arc MRN, let's call it that. Arc MRN equals a fraction. What fraction? 168 over 360 times the circumference of the whole circle would have been 2 pi times the radius of 12. All right, 2 pi r. Remember, the circumference is 2 pi r. So what is this form? What is this here that I did? This was theta over 360 times the circumference is 2 pi r. That's what I have here. And we can just work that out and see what that arc length is. I'm just putting it on the diagram there. So let's work this out with the calculator. Remember that I must use the pi as 22 over 7, right? Up here. Use the pi as 22 over 7. Right here. That's what I said. So I'm going to show this calculation. So it becomes a fraction of 168 over 360 fraction not be able to show times 2 times the want us to use 22 over 7 as a pi. Then multiply that now again by the radius of 12. That's 35.2. 35.2, that's 35.2 centimeters is the arc length around here. And so the perimeter of the metal, the perimeter that I want, the perimeter becomes radius plus radius. So when I say arc plus 2 times the radius, this arc is going to become 35.2 plus 2 times that radius of 12. So what we have on the paper on the screen, I can just add 2 times 12 to it. 24. That's 57.9. No, 59.2. What am I saying? 59.2 centimeters is the perimeter of that shape. But go to that. But okay.
Yes, sir.
Yes, sir.
Good. Let's continue. I say a cone is made from the sector in A by joining OM and ON. All right. So this flat shape is used to make this cone by joining this to this. And this point becomes the apex O of the top. So let's imagine that you have this shape. This is called the net of the cone. The net of the cone. The net is a flat surface that shapes out the cone. That is used to shape out the cone. But another way, take the cone and you flat it out into a plain shape. That plain shape is called the net. This is the net of the cone. So just imagine you take this point O and you pull it upwards off the flat surface up towards you. And these 2 points will eventually come around and join each other and become these 2 points. And in fact, all of this arc will become the base of the cone, like so. And then this point will be up in the middle here. So the M and the N will join, M and the N. So this R maybe will be around here. And then this point O will be up here. And then now we have these 2 sides. Now remember that this ON of 12 is actually this side over here now on the cone, right? And this MN is also here. They join together. And so when you pull up this middle section vertically upwards towards you, and such that this and this come around and join. Means that this side and this side also join from here. So we know that right here is 12. Now we also know that this arc, which you know the arc length, has become the base circumference of a cone. That's what we need to know. That's what we need to realize. That arc length that we just calculate is now the circumference of the base of a cone. All right, and this side is now the slant height of that cone, and slant length there of that cone. But that's what I'm saying. Understand what I've said?
Yes, sir.
That, right? So you can visualize that, then you're good to go. All right. So remember, this arc length, full arc length is now the circumference of the base, because this and this point are joined together to form the base, circular base of that cone. All right, that's what I want us to do. So we know that this side is 12. You can put it down from now. This is 12. This is also 12. Right, but this in particular, because remember the OM and the ON in this 12, they're joined together. I want to know that the circumference of this piece, circumference, was the arc length a while ago. Circumference is equal to the arc that we had before. It was arc again. It was it was M, it was NRM. NRM. Arc NRM. So they don't show back R in this diagram, but the R maybe will be somewhere around here on this diagram. It will just show it. All right. The question is asking us for the radius of the cone. We're gonna get the radius of the cone because we know the circumference of the base is what the arc was. What was it again? 59.2. That's 59.2 centimeters. So because we know the circumference of the base is 59.2, we can equate the formula for the circumference to 59.2. This circumference, which is 2 pi r, is equal to that. This r and that now. Right? The r that we use up here a while ago was the r on the sector, not the r on the base. The r that we use in this formula up here was the r on the sector. The r down here now is the r that we're talking about on the base of the cone. So 2 pi r is equal to this. All right, circumference. So we can write that. So 2 pi r is equal to that. What was the arc length a while ago, which is 59.2. All right, so you want to find the r divided by the 2 pi. So the r equals 59.2 divided by the 2 pi. Remember the pi split was 7. I'm going to just write it here. And the 2 was 7 by the pi. We put that in the calculator. But understand the calculation? But understand the calculation and the reasoning?
Yes, sir.
All right. If you did it before, you understand it now, go and do the question. Go and do the question. More maths equals better maths. So I'm doing this calculation right here, as it said. So it comes 59.2 over 2 times 22 over 7. And that becomes 9.42. Let's keep the 3 simple figures. That's 9.42 centimeters is now the radius of the base of a cone. And this one says calculate the height. So the height, get the height now, which is the h. We're gonna come and work in this triangle. We have to know that this is 12. After working in this right angle triangle now, when use Pythagoras theorem to find the height. This is the hypotenuse. So this side squared, write it out. Means that, let's write out Pythagoras theorem. It means that the hypotenuse squared to the 12 squared So they don't give a lot of space, guys. So they expect you to just know that the h is going to be the square root of 12 squared minus this radius squared, which is this. But I can understand that. That's using Pythagoras' theorem. Got to go with that. Pythagoras' theorem.
Yes, sir.
All right, so you work this out with the calculator now. So I'm gonna put the square root of 12 squared minus 9.42 squared. And it is the height is 7.43 centimeters. And the height of the cone. Question like this you need to redo now, guys. All right, redo the question. Connect the net with the cone, the parts, the dimensions. All right, redo it. Remember that this is not part of the theorem, right? We just start right over here. That the 12 squared is equal to the 8 squared plus the r squared. So take the r squared and subtract over here. Then we're gonna get that 12 squared minus the radius squared is equal to the h squared. If it's h you want, you're gonna square root this side and square root that side. So the h alone is gonna become the square root of 12 squared minus the radius squared, which is what we have using here. All right, and that's Pythagoras' theorem. All right, leaving that right there, Pythagoras' theorem. All right, this one says no, calculate the capacity of the cone and I want it in liters. So to get it in liters, you have to know that 1,000 cm cubed is actually equal to 1 liter. All right, but I want the capacity of the cone. Capacity of the cone, capacity means volume to full volume. So the capacity is the volume to full volume. All right, volume required to full of space is the capacity. Capacity, am I right here? Capacity is 1/3 I r squared e. That formula give for the volume of a cone. 1/3, the pi is 22/7. The r is this r that we just found, the radius of a cone. Where is it? 9.42. And the height that we just calculated a while ago is 7.43. Put all of that in the calculator and get it. So 1/3 times pi, which is 22/7, on the calculator times 9.42 times 7.43. Now notice I'm using 3 significant figures for those values that we calculated that were not exact, but that's a standard. When you're calculating something in CSEC and the answer is not exact and the question did not tell you how accurately you should give your answer, practice to give it to 3 significant figures. That's a standard. All right, 3 significant figures like this one now, which is 72.32 something. I'm just gonna write 73.3, and that is capacity centimeters cubed. See, I'm giving it to 3 significant figures. I'm not giving it to decimal places. I'm giving it to significant figures. And that is it. All right, to myself. So I give these to 2 decimal places. I'm giving this to 1 decimal place. No, I'm giving them to 3 significant figures. All right, so that is a standard. But I want it in liters, right? This is same cm cube. So to get it in liters, you have to divide this now by 1,000. Right? because 1,000 is 1. So to get this to liter, we're going to divide by 1,000. So divide by 1,000, we decimal place 3 places to the left. All right, so it's going to become 0.0. 3 places to the left. 1, 2, 3. 1 0 in between there. So 0.07. 0.733 liters. That's it. So I'll get back this, I'll multiply by 1,000. 1, 2, 3, right? So that's the liters. But good? But okay with that?
Sir, for
Yes,
the
sir.
Yes, somebody have a question?
yes, sir, for the 9.42, sir, that's the radius, sir. So we don't square it.
Where? Let's see.
Where you say capacity is
Oh, I'm supposed to
what?
square that. Thank you very much. Thank you for that. Yeah, I'm supposed to square it right here. All right, good. Supposed to square it. My mistake. All right, so this answer has to be, this answer must be corrected then. All right, so I never said what I was doing it. But wait till I finish. I mistake that. All right, so I'm supposed to square it. So I have it in the formula here now. I feel to square it there. All right, so I would have lost mark for that. I would have gotten, let me see much mark this value. 2, maybe get 1 out of it. But I have the right formula. I just fail to square it here. Well, let's put, so that is actually 690 something. All right, so it's 690 point. So you might ask me, why am I writing it so many digits now? Because I'm converting it to so it's going to be 691. I'm working 3 simple figures. What's put the 0.7 instead? 0.7. I've gone past 3 significant figures already. So this is okay. CM cube. Divide this by 1,000. 1, 2, 3 decimal point comes here. You can actually put 0.6907. I could just put a 1 right here. For 3 simple figures and put liters. Right. I could have used 3 significant figures on this line and just put 691. 3 significant figures, CM cube, which would then give me this amount of liters. It divide by 1,000. All right, thanks for that. Thanks for that correction. The very last thing that we're doing. Yes, imagine the very last thing we're doing for today. That's what it is. Everybody good? Everybody okay with that?
Yes, sir.
Yes,
So
sir.
we're gonna pick it up back tomorrow, right here. So I'm giving you time, and this is a question that we did the other day as well. But as I said, no problem. More massive better maths every time. All these questions we maybe do already at some point, but no problem. That's how it is. We need to practice and revise and review. Just get these questions comfortable. All right, so we're gonna start back here tomorrow. I'll just have focus on number 7, 8, 9, and 10 tomorrow. All right, so hopefully you will attend the session. I'm trying to try aim for to have a session at the normal class time of 5 p.m. Right, online. All right, so that is the plan. And I'll just send the link. Any change, I send a message in the group. Okay, everybody? All right.
Yes, sir.
All right, so when you redo the questions, do them, send and let me see, please. So that let me know that you're working on this thing. It's business time now, guys. Serious time now. No more time to joke. All right, so I have to put in the work. No want the result, let's put in the work. All right, bye, everybody. See you tomorrow. See you all tomorrow. I'm gonna send the video to the group right away. All right, bye. Mr. Mills, no food today.
Bye, sir.
No food today, Mr. Mills. Bye.
But no, sir, no, sir.
Yeah, yeah. All right. Bye, everybody.
Bye, sir.
Come on.